Sketch the graph of the polar equation r equals 3 times the cosine of theta. What we're going to do is make a table of values as a starting point. We can work algebraically with this equation as well and see what it looks like in Cartesian form. But let's first make a table of values. If theta is equal to 0, then cosine of theta is equal to 1, and 3 cosine of theta will equal 3, and that will give us the radius for the equation, the graph, at an angle of 0 radians. So if we go in the 0 radian direction, we have to go out 3 units, and we'll use the every other circle as 1 unit here. So there's a point on our graph. If we also look at pi over 6, or a 30-degree angle, the cosine of 30 degrees, or pi over 6, is the square root of 3 over 2, and when we multiply that by 3, we get 3 root 3 over 2, which is about 2.6 or so. So along this line corresponding to a pi over 6 angle, we have to go out 2.6. So 1, 2, and 2.6 is about here. If we go to pi over 3, that cosine of pi over 3 is 1/2, and 3 times that is 3/2. So along the line corresponding to an angle of pi over 3 radians, we need to go 1.5 units. There's 1.5. And if we go to pi over 2, cosine is 0 there, so 3 times 0 is still 0, and we're going, when we are facing north, facing pi over 2 radians, we go nowhere. We could continue this process, but I'm starting to get the sense that this may be a circle. Now you could continue plotting individual angles, and maybe we should do one more of those. The next would be 2 pi over 3, so we're facing along this line, and the cosine of 2 pi over 3 is the opposite of the cosine of pi over 3. That's going to be negative 1/2. And so 3 times that is negative 3/2. So as we're facing along this line, our r value is negative 3/2, which means we need to go backwards 1.5 units, and we end up here. We can do maybe one more. If we do 5 pi over 6, that's the next line that's marked on my polar grid paper. Cosine there will be negative root 3 over 2, and 3 times that will be negative 2.6. I'm just borrowing from this line, only using the negative sign there. And so I'm facing along this line, but I have a negative distance to travel, so I go 1, 2.6 about here. And you can see that the shape that's been traced out here appears to be circular in nature. We can confirm that that's the case by working with the equation r equals 3 cosine theta and converting that to a Cartesian equation. Best thing to do is multiply both sides by r. And so r squared is x squared plus y squared based on one of the fundamental relationships between polar and Cartesian form. And r cosine theta is just x. So this is x squared plus y squared equals 3x. And that is the equation of a circle. If we complete the square on this expression, we'll obtain the equation of the circle, and that's going to be centered at 3, 0. I'll show you that work here in just a second. There we go. I popped up the work needed to complete the square, and it's a good thing I did, because I think I misspoke a second ago. This is a circle centered at 3/2, 0, and the radius will be 3/2, and we can see if we go out 1.5 units, we're here. That'll be the center of the circle, and if we go back 1.5 or forward 1.5, we'll get to the corresponding points on the circle that we had sketched by plotting individual points in polar form earlier.